Hello students, I am Dheeraj Soni, and in this session we are going to discuss about applications of gyroscopic effect for aeroplane during steering. See what is the effect of gyroscopic couple on an aeroplane. So before starting or studying about this topic, first of all we are going to see the top view and front view of an aeroplane. See in the top view we can see this is the front end and this is the rear end. The front end is also known as the nose end and the rear end is also known as the tail end. At the front end, propeller is mounted and the direction of viewing may be either from the rear end or from the front end. And the aeroplane can take turn either in left direction or in right direction. And if we talk about the when vehicle is taking turn or aeroplane is taking turn, two kinds of couples are created over there. The first is the active gyroscopic couple and second one is the reactive gyroscopic couple. The one couple is responsible for turning of the body, another couple is responsible for orientation or balancing of the body. And while we see the axis of this turning action, this is the first axis called axis of spin, at which propeller is taking place in the rotation direction, and the another axis which is perpendicular to axis of spin, that is called axis of precision, and the third axis is axis of active gyroscopic couple. And just opposite to axis of gyroscopic couple, there is one more axis which can be treated as OZ dash, that is called axis of reactive gyroscopic couple. And with respect to these three axes, there are three planes also. The first plane is called plane of spinning, that is OYZ plane. The second plane is called plane of couple. The couple may be either reactive gyroscopic couple or active gyroscopic couple. These plane are represented by OY X, and third plane is called plane of precision, which is represented by OXZ. So taking into consideration these all three axes and three planes, now we are going to discuss that how gyroscopic couple will affect the aeroplane position when it's taking either left turn or right turn. So for studying this condition, let's suppose we are taking the first case when aeroplane is taking left turn as shown in the figure, and the nose end at which propeller is mounted, this is taking rotation in clockwise direction. This may be in either clockwise direction or in anti-clockwise direction. But for this condition, the propeller is taking clockwise direction turn and the direction of viewing is from rear end. So we are taking three cases. First is the left end, second is the clockwise motion of the propeller, and third one is direction of viewing is the rear end. So how these three conditions will impact the effect of aeroplane? We can see the amount of gyroscopic couple or the value of gyroscopic couple here created will be C equals to I omega p, where I is called moment of inertia, omega is called angular velocity, and omega p is called precisional angular velocity. So for identifying the value of precisional angular velocity omega p, we can have the formula also V upon R, where V is known as the linear velocity of the aeroplane in meter per second, and R is called radius of curvature when vehicle is taking turn either in left direction or in right direction, and this can be taken in the terms of meters. So V by R will be equals to omega p taken in the units of radian per second. And for identifying the value of I, we can have the formula I is equals to mass moment of inertia of the engine and propeller, that is equals to mk square. M is mass of the engine and propeller in kilogram, and k is it's a radius of gyration in meters. So the value of I will be in terms of kilogram into meter square. So if we are having the value of I, omega and omega p, so by multiplying or by product of these three values, we can find out the value of C, and this C is known as gyroscopic couple. This gyroscopic couple value will be responsible for producing gyroscopic effect in the aeroplane for orientation of the aeroplane while it's taking turn either in left direction or right direction. Now see in this figure what conditions may arise here. The first condition when aeroplane is taking left turn, or the second condition when aeroplane is taking right turn. Let's suppose OX is the original axis or initial axis of spinning, and when speed is somewhat increased, then OX will be shifted by a certain angle del theta, and the new axis is OX dash. So here by arrow we can see this is the direction of gyroscopic couple, and just opposite to this direction there is one more couple that is called active gyroscopic couple and reactive gyroscopic couple, which will be used for orientation or balancing of the body. And this same condition may be taken or assumed just opposite to the first condition when vehicle is taking a right turn. So OX will be shifted in downward direction or right direction. Here OX is shifting in upward direction or left direction. So these are the two cases when aeroplane can be steered as per the requirement. So C, we have find out the value of C, that is equals to I omega omega p, that is gyroscopic couple. So after identifying the value of C, the main condition arises that what will be with nose end and tail end, because for balancing purpose or for producing gyroscopic effect, C is certain amount which is responsible for producing this effect. But for producing this effect, there will be certain changes in the position of the aeroplane from front end and rear end. So this table will show you directly that what will be the impact when vehicle is taking turn. So major impact will be on nose end and tail end. So by this table we can clarify the actual effect by identifying these three conditions of aeroplane rotation. The first condition, what is the view direction? First of all, when you are going to solve the numerical problem in respect to this problem, this condition or this topic, first one condition we have to note that what is the view direction. The view direction may be either rear end or front end. That means the viewer may be at the rear end or the viewer may be at the front end. In the figure we can see here, right now we have assumed the direction of view is from the rear end, and the vehicle is taking left turn, and the nose is moving or the propeller is rotating in clockwise direction. This condition may be assumed just opposite to that also. So again we are proceeding towards the table part. So direction of view is rear, and the turning direction may be either left or right. So first case we are taking the turning direction in left direction, and the rotation of propeller, rotation of engine, that is in clockwise direction. So the main problem arises that if these three conditions are given, then what will be the effect of nose and tail? So the effect of nose is what? The nose will raise, and the dip condition will be achieved by the tail when we are viewing from the rear end and direction of turning of the vehicle is left and engine is rotating in clockwise direction. So for producing a proper amount of gyroscopic effect or for proper balancing or orientation of the aeroplane, what is the must condition? The nose end should raise and tail end should dip, so that proper steering can be taken by the aeroplane. And if we are assuming just opposite condition, that means again we are viewing from the rear, but the direction of turning is right instead of left, while the engine is again rotating in clockwise direction, the condition will be opposite. The nose end will dip while the tail end will raise. And again we are just opposing the condition of rotation of the engine. That means if engine is rotating, instead of clockwise it is rotating in anti-clockwise direction, then the condition will again be reverse of first case. That means when the engine was rotating in clockwise direction, the nose end will raise and tail end will dip. But for this anti-clockwise direction, the nose end will dip and the tail end will raise. And again, we are changing the direction of steering. So we are taking left and right. So for right condition, the condition will be just opposite to the left condition. So depend will be replaced by resent, and resent will be replaced by depend. So these are the four conditions: first, second, third, and fourth, when the person is viewing from the rear end. And if we are just changing the position of the person which is viewing from the front end, then all the situation will be reversed. So this table will be highly helpful for solving the numerical problem and for identifying the effect of gyroscopic couple, that how it will be produced when these three conditions are varied. Thank you.